Greetings. Uh, I am Dr. Dinesh, professor in Electrical Engineering College. I have experience of nearly 20 years in teaching the industry. My area of interest is optical communication, optical networks, and VLSI. Now I am going to give a brief idea about the principle and elements of optical communication. You know that communication means sharing of information from one place to another. In electronics, we have different types of communication, satellite communication, microwave communication, RF communication. And why particularly we are giving more importance to optical communication is last 10 years, it is having a huge demand related to marketing, and also it is giving a good opportunity, lot of EC engineers. At the same time, it is giving a good applications. So in this session, we are going to discuss about the principle and elements of optical communication. So as I told you, communication means sharing of information from one place to another. In optical communication, it is a method of transmitting information from one place to another by sending light through an optical fiber. So optical communication, optical fiber is the transmission medium. So this is the block diagram related to the optical communication. We have three basic elements of optical communication. One is the transmitter, and second one is the channel. Third one is the receiver. So similar to the communication, here also we have three important elements. In transmitter, the input is the electrical signal. With the help of modulation and the optical light source, you are going to convert the electrical signal into an optical signal. Mostly in optical communication, we are using laser and LED as an optical source. So the transmitter, it converts the electrical input signal into an optical signal by following the intensity modulation. So next, we have a connectors and splicers. These are the important components related to optical communication connection. Suppose you want to connect a link between one place to another and the distance is 80 kilometers, you won't get a optical fiber with a length of 80 kilometers. So what is the solution? We have to connect different optical fibers. Now the question is how you are going to connect, whether you want a permanent connection or a temporary connection. Whenever you want a permanent connection, we can use the method called optical splicing. So whenever you want to discharge the connection after the process, you can go for the connector because connector is a temporary connection. So as I told earlier, optical fiber is a transmission media. This is the channel part. So after converting the electrical signal into an optical signal, you have to transmit the optical signal through the optical fiber. Then you have see an important component, optical coupler or splitter. So whenever you want to couple two optical signals, we can combine with the help of optical coupler. Suppose you want to separate optical signals into two, that is possible with the help of D splitter. Then you have a regenerator. So in optical communication, we have three generations, first window, second window, and third window. In these three windows or in this three generation, you have a tremendous development. An important development is the optical amplifier. Because before optical amplifier, whenever you want to amplify the optical signal, first you need to convert the optical signal into an electrical signal because we have only electrical amplifiers. So after amplification, once again you need to convert the electrical signal into an optical signal. But optical amplifier, without conversion, it will do the amplification straight. That means an optical amplifier will amplify the optical signal. Okay. Then coming to the receiver part. A receiver part, it will do the reverse process of transmitter. So in the transmitter side, we have converted the electrical input signal into an optical signal. And in the receiver side, we need to convert the optical signal into an electrical signal. So for that, we are using the photodetector. It may be a pin photodiodes or avalanche photodiodes because these two are the important detectors we are using in optical communication. So it will convert the optical signal into an electrical signal with the help of demodulation. Then you have an amplifier. So we need to convert the converted electrical signal to send them the signal. We are using the amplifier. So after that, we have a signal restorer to restore the signal, and you are getting the electrical output. So what input signal you are giving, that will be transferred to the output based on three processes. So transmitter, it will convert the input electrical signal into an optical signal. The signal is transmitted through the channel, and receiver, it is going to convert the optical signal into an electrical signal. Okay. So even though you have different elements, the three elements, important elements in optical fiber is the optical source for converting electrical to optical signal, the optical channel or optical fiber, and third one is the optical detector. It will convert the optical signal into an electrical signal. So just now I have told you these are the important things. Key sections of receiver. I have told you photodetector, amplification, signal restoration circuit, and here one important component is fly lead or pigtail. In some situations, for small connections, we need a small optical fiber. So we'll call that small optical fiber as a fly lead or pigtail. It may be 2 meter length or 1 meter length. Okay. So fiber connectors, I have told you what is the difference between fiber connector and fiber splicing. Next is the ray theory or geometry theory. So in optical fiber, we are transmitting the information through the optical fiber by following the principle called total internal reflection. That is based on ray theory. The ray theory is based on the concept of reflection and refraction of light. So in optical fiber communication, we are considering light waves as waves. At the same time, we are dealing the ray theory by considering light wave as a ray. So these are the basic terms we need to know before understanding the ray theory. First one is the refraction. So refraction, you know that the bending of light that plays at the boundary. Boundary means in optical fiber communication, whenever you want to transmit the light, you need two types of medium. One is a denser medium and the second one is the rarer medium. So boundary is a place to connect the two mediums. One is the denser medium and second is the rarer medium. And we have two types of rays. Instant ray. So we can say the input ray approaching the boundary at angle of instance. And refracted ray is, it is refracted from the boundary through the second medium. So we have two types of medium. The denser medium represents the whenever the medium is having high refractive index, we can call the as an optical denser medium. Whenever the medium is having low refractive index, we can call it as an optical rarer medium. So whenever you have two medium, which medium is having higher value, then we can call that as a denser medium, and which medium has a lower RA value, we can call that as a rarer medium. So that's what I have told. You have glass and air. We have two mediums. Based on the refractive index value, glass is the denser medium and air is the rarer medium. So you are transmitting an instant ray. Whenever you are increasing the angle of instant, the angular refraction also increases. So the ray will be refracted. You can see this. Whenever light travels from optically denser medium to rarer medium, light bends away from the normal. So here we are discussing the total internal reflection phenomena with the help of three cases. Case one is you are giving an instant light. That light will be reflected at the boundary region. Now, case two, you are going to increase the angle of instance. Whenever angle of incidence increases, angle of refraction will also increases. You are keep on increasing the angle of incidence. Based on that, the angle of refraction will also increases. But until the angle of refraction reaches 90 degree. Case 2. If you still increase the angle of incidence, instead of refraction, the whole ray will be reflected. This reflected ray is called as total internal reflected ray, and the phenomenon is called as total internal reflection. So we have two rays. So based on the Snell's law, we have sin I by sin r is equal to n2 by n1. N2 represents the refract index of the second medium. N1 represents refract index of the first medium. So I told you, whenever you are increasing the angle of incidence, the angular refraction will also increases. But one particular time, it reaches 90 degree. At that time, we can call the incident ray as an critical ray. Okay. So whenever the refracted ray reaches 90, at that time, we can call the incident ray as a critical ray. Critical ray is represented by theta c. So sin theta is equal to n2 by n1 because the sin 90 is 1. Therefore, the expression for critical ray is equal to sin inverse of n2 by n1. So thank you. I hope in this session you have understood what do you mean by optical communication, what are the important elements of optical fiber communication, how the important elements and supporting elements contributing for the optical fiber communication, on what basis we have transmitted the incident ray, and what principle the ray is refracted and also reflected. Everything we have discussed. Thank you.